Hello everyone, my name is Karan Mashru. Welcome to this video. So in this video we are going to look at the solutions of the problems which were asked in Weekly Coding Contest 137. First of all, let us start with the first question. So the first question is Candy Shop 1. So let us start by understanding the question. Geek is at a candy shop with n candies. So there are n candies at a candy shop. The candies are represented as candies where the ith candy is represented by its price. So this is one array which we are given and the ith element represents the price of the ith candy. Two candies are different if their prices are different. So if two candies have different price, we consider them different candies. If two candies have same price, we consider them the same candies. Geek wants to test all different types of candies, but he wants to minimize his expenditure. So all the different types of candies available possible he wants to test, but he also wants to minimize the cost. Okay, because if he purchases ith candy, then the price which is associated with the ith candy he would have to pay. Okay, help Geek find the minimum amount that he needs to spend so that he could buy at least one candy of all types. So we need to tell what is the minimum amount of money the Geek needs to spend so that he can try all the types of candies. Okay, so for example, here n equals to 4 and there are 4 candies. The prices are 1, 4, 5, 1. So the first and the last candy is same, and in total there are 3 types, 1, 4 and 5. So Geek can buy this candy and this candy. So there will be 3 candies. He will try candies of all the types and the total cost would be 5 plus 4 plus 1, that is 10. You do not need to take both these candies because this is all, these and these are same type of candies. And we want to minimize the cost, so we will take only one of it. Okay, so total cost is 10. Similarly, you can have a look at this example. You don't need to read, input or print anything. Your task is to complete the function candy shop that takes n as an integer array candies and an input and return the minimum amount Geek have to spend to buy at least one candy of all types. So we need to complete this function where we will be given n, that is the number of candies, and the candies array which will represent the price, and we will have to return the minimum amount to try at least one candy of all types, and the constraints are given here. So now if we think about solving this problem, then let us look at this example. There n equals to 10, so there are 10 candies and these are the price of 10 candies. Now what is asked in the question? What is the minimum amount Geek needs to spend in order to try all the candies? Now if he wants to try out all the candies, he must purchase all the candy, at least one candy of all the types, right? And how do we define different types? Two candies are different if they have different price. Okay, and two candies are same if they have same price. So basically Geek wants to buy at least one candy of all different prices. Okay, that is the thing. Another thing is he want to maximize the minimize the expenditure, the amount he spends. So he will buy only the bare minimum required candies. So what he will do is he will buy one candy each of every type. Okay, because at least one he have to try, that is given in the question, and there is no need to try more than one candy of the same type because we want to minimize the expenditure. So if I look at the example here, so what I will do is there is one candy whose cost is 1. I will take either of them. So let the Geek take this one. Then there is 2 candies of cost 3. These are also same. Geek will take this. Then there is only one candy with price 2, so Geek will take this. Then there are 3 candies with cost 5, so Geek will take one because all 3 of them are same. Then 6 and 9 are occurring only once, so Geek will take them also. So Geek have to try at least one candy of all different types. So we have included all different types, right? So this is the bare minimum, and he wants to minimize the expenditure. So now if I take one more candy of, let's say, cost 5, in this example also all the different types of candies are included, but this is not the minimum. What is the minimum cost? Take one candy each of each cost. Okay, so we will not take this. Okay, so basically what we will do is we will take all the unique cost candies, all the unique costs which are there in the array, and just add them up. So what will be the answer for this question? This will be 1 plus 3 4 plus 2 6 plus 5 11 and 6 17 and 9, that is 26. So the answer for this question would be 26. Now how would we implement this? So basically we want to take one candy of each cost present in the array. So what I can do is I can make a boolean array of cost, okay, of the range of cost. Let us assume that the range of cost here is 1 to 10. Okay, you cannot see any candy which is more than that, right? So I will take a boolean array of size, let's say 11. Okay, so this will be 0 index, 1 index, 2 index, 3 index, 4, 5, 6, 7, 8, 9 and 10. Now what I will do is, initially I will mark all of them as false. What does false and true mean? False means we do not have the candy of that price, and true means we have candy of that type. Now I will traverse this array and I will make the respective indexes true. For this, for example, here the cost is 1, so I will make this true. Here the cost is 3, so I will make this true. Here the cost is 3, it is already true. Here the cost is 1, this is also already true. Cost is 2, I will make it true. Cost is 5, I will make it true. Cost is 5, cost is 5, cost is 6, I will make it true. And cost is 9, I will make it true. And this will remain false. So this will be my array. So now what does this represent? Wherever there is true, those type of candies we have. So I'll again traverse the array, and wherever there is true, I'll just add that number to my answer. So I'll say 1 plus 2 plus 3 plus 5 plus 6 plus 9, and this will be my answer. Okay, now let's look at its actual implementation. So if you look at the actual implementation, so in the actual constraints, the cost can go from 1 to 1000. Okay, the maximum cost of any candy can go from 1 to 1000 as given in the constraints. So I will take one boolean array of size 1001. So I can get indexes from 0 to 1000. I'll take one answer variable which is initialized to 0 and some more variables to iterate. I will make all these elements as false initially. Okay, then I will traverse the array and I will say candies of I equals to true, like how I said here. Your candies of I is what? I is equal to 1, this is 1 index, and candies of I is nothing but what? 3. So I need to make element with index 3 true. So I need to make element with index 3 true because the cost associated with the ith candy is 3. Okay, so that is what I am doing here. F of candies of I equals to true. Then I will just traverse over the range of the price, and if f of I is true, it means the candy with cost I exists. Now there can be multiple candies, but we do not have to worry about that. We have to take only one, so I'll just add I cost candy to my answer, and finally I will return the answer. What would be the time complexity? It would be big O of n. And what would be the auxiliary space? The auxiliary space here, this is 1000 size array. Okay, so we can say big O of 1000 or the range of prices. Okay, so this is the time complexity and this is the auxiliary space. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you understood the solution completely. So now let's look at question number 2 of this contest. So it is substrings with same value. So let us start by understanding the question. It says, given a string s of length n, count the total number of substrings of s that have the same value as s. The value of a string is defined as the ASCII value of the first character of the string. Okay, so what does this mean is that we need to tell, see, if we are considering a string or a substring, then the value of that substring is what? It is equal to the ASCII value of the first character of that substring. Okay, and here we are said that we need to count total number of substrings that have same value as s. S means the original string. Means what is the value of the original string? ASCII value of the first character. So basically we need to tell the number of substrings which have the same first character as the original string. Okay, and we need to return it modulo 10 to the power 9 plus 7. So for example, here the first character is a. The value of s is what? The ASCII value of small a, that is 97. So we need to return the number of substrings whose value is also 97. Means the number of substrings whose first character is a. Means the number of substrings basically starting with a, right? So what I can do is, see, one is a, another is ab, another is aba, right? These are 3 because they start with this, and another is this second a single. Okay, so you can see here there are 4 substrings possible, so output is 4. Here the output is 6. You don't need to read input or print anything. Your task is to complete the function total count, which takes size n and string s as input, and return the count of the total substrings of s that have same value as s. And the constraints are given here. So if we think about solving this problem, then if we consider this example, so basically we need to count the number of substrings. Okay, count the number of substrings whose value is same as original string s. Here how is the value of a string defined? It is defined as the ASCII value of the first character of that string, okay, of the first character of that string or substring, whichever we are considering. So what is the value of this string? It is 97, because the ASCII value of the first character is 97. So we need to return the number of substrings of this string whose value is 97, means whose first character ASCII value is 97, means whose first character is small a, basically. So can I say it will be nothing but the number of substrings starting with this character plus the number of substrings starting with this character plus the number of substrings starting with this character? Basically, I want to find the number of substrings who have the same starting character as the original string, right? Original string has the starting character as a, so I want to find the number of substrings with the starting character a. So I can say number of substrings starting with this a plus number of substrings starting with this a plus number of substrings starting with this a. So how many are there? If I write down here, it is a. If I write down the strings starting with this a, then it is a, b, c, a, b, c, a, b, c, a, b, a, b, c, a, b, d, then a, b, c, a, b, d, a, and a, b, c, a, b, d, a, p, right? Then starting with this a, how many are there? A, b, d, a, p, a, b, d, a, b, d, a, b, and a. And starting with this a, how many are there? A and AP. So total it would be 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 plus 3, 3, 6 and 2, 8. 8 plus 5 plus 2, which is nothing but 15. Okay. So now basically we want to find the number of substrings who have the same starting character as the first character of the original string. So how can we calculate it efficiently? So see, what I can do is, if I want to count the number of substrings starting with index I, and if the length of the string is n, then directly the number of substrings starting with index I is n minus I. I can say this. For example, here the value of n is how much? 8. Total length of the string is 8. The value of I here is 0. Here the value of I is 3. And here the value of I is 6. So the number of substrings starting with this index is n minus I, that is nothing but 8 minus 0, that is nothing but 8. Number of substrings starting with index 3 is n minus I, that is 8 minus 3, that is 5, we can see here. And the number of substrings starting with this index is n minus I, that is 8 minus 6, that is 2, that we can see here. Right? So what I will basically do is, I will traverse the string, and whenever the ith character is same as the first character, 0th character, I will consider all the substrings starting with index I, and that is nothing but a total number of substrings starting with index I is n minus I. So I will add n minus I to my answer. Now let's look at its actual implementation. So if you look at the actual implementation, so what I have done here is, I have taken mod value as 10 to the power 9 plus 7. I have taken one answer variable as 0 and two variables to iterate, and then for I equals to 0 to n, if the ith character is same as 0th character, it means all the substrings starting with ith character can be added to the answer. So I will say answer equal to answer plus n minus I, and finally I will return the answer. I have not taken your modulo 10 to the power 9 plus 7, you can take it, but since the constraints are small, I think n value can go up to 10 to the power 5. So your total number of substrings only will not exceed mod value, right? So there is no meaning of applying mod, and finally you can return the answer value. What is the time complexities? Big O of n, because you are running a for loop of size n. What is the auxiliary space? The auxiliary space here is constant, because you are only taking a few variables. Now let's submit this code. Okay, so let's submit it. Okay, so we have solved this question successfully. Now let's move to third question. So now let's discuss the third question, that is candy shop. So first of all, let us start by understanding the question. Geek is at a candy shop with n candies. There are n candies in a shop. The candies are represented as candies. So this is an array where the ith candy is represented by its price. So we have an array candies where candies of I will represent the price of the ith candy. two candies are different if their prices are different. So if two prices are same, the candies are same. If prices are different, candies are different. Geek wants to test all different types of candies, but he wants to minimize his expenditure. Okay, so he wants to test all types of candies. Okay, so all types of candies means all different prices of candies he want to test. Okay, but he wants to minimize his expenditure, but he wants to purchase as minimum candies as possible, but which includes at least one candy of all the type, right? Geek could only buy candies in continuation. He could buy any subarray of candies. Okay, so now what is the condition here? Geek can buy any subarray of candies. Okay, and he want to buy it in such a way that he can test all different types of candies, means all the unique price candies, as well as the expenditure is minimum. So we need to take care of both these things, and we need to buy the candies only in continuous manner. Help Geek find minimum amount that he needs to spend so that he could buy at least one candy of all the types. Okay, so what is the minimum amount Geek need to spend such that he buys in continuation, means in subarray, and he can test at least one candy of all type, and the expenditure is minimum. So for example, here for n equals to 4, there are three different types of candies, 1, 4 and 5. So Geek can test this first three candies, which total cost will be 10. See, he can also buy all four candies, which is a subarray and which also contains all unique types of candies. But in order to minimize the cost, we will try not to repeat the same price candies. So with this subarray of size 3, we can get all three types of candies, so that minimum cost is 10. Here, what he can do is, see, there are three types, 1, 2, 2, 4, 1, 2 and 4. So what he can do is, he can see, he need to take 1, he need to take 4. So he need to take this subarray. Now if he takes this subarray, 2 is already taken, so no need to take this 2. So the total is 4 plus 2, 6 plus 2, 8 plus 1, 9. So the output is 9. You don't need to read input or print anything. Your task is to complete the function candy shop that takes an integer n and an integer array candies as input, and return the minimum amount Geek have to spend to buy at least one candy of all types when he could buy only in continuation, and the constraints are given here. So now if we think about solving this problem, so see, here I have taken two examples, n equal to 10 and n equal to 5. What Geek needs to do, first of all, he can buy candies only in continuation. Okay, these are the prices of the candy. He can buy candies only in continuation. So he can buy candies, he can buy subarrays of candies. Okay, first thing. Second thing, he needs to minimize the expenditure. Okay, so he will buy as minimum candies as possible. Third thing, he wants to test all different types of candies. So he need to purchase at least one candy of each price. Why? Because here it is said that if prices of candies are same, they are of same time. If prices of candy are different, they are of different type. And if he wants to test each candy of one, he wants to test candies of all types, he need to purchase at least one candy of each price, means at least one candy of each type. Okay, and he also wants to minimize the expenditure, so he will make sure that he tries to avoid repetition of same price at max whenever possible. And here it is said that you buy candies only in continuation. Now see, one way to solve here is, first of all, calculate the unique number of candies which are there. Okay, so here the unique number of candies is 1, 2, 3, 4 and 5. So here let's say I will say f, that is frequency, is 5, and here the frequency is 3, 1, 2 and 4. Okay. Now one way to solve this problem is to basically calculate for all subarrays, check the number of unique candies and calculate the total value. If the number of unique candies in that subarray is equal to the frequency, means there is at least one candy of each type, then compare that subarray's cost, that is the sum of candies of that subarray, with my answer variable. Maintain an answer variable and take the minimum value out of all such subarrays which contains all unique candies with the answer variable, and take the minimum value in the answer variable and finally return it. But if you try to do this for all the subarrays, then your time complexity will be big O of n square, right? And this will give you time limit exceeded. So you need to think of something more efficient. So what I can do here is, see, I can use here something like a 2-pointer. Like I will start from left. I will say I will try to maintain a window and I will maintain that using two pointers. First of all, both the pointers will be pointing to the left, and I will try to increase the window size. Okay, when I increase the window size, I will see the number of unique candies in that window. If it is equal to the frequency, that is the total number of unique candies, then I will compare the sum of those candies with my answer variable, and I will try to reduce this window side from the left side. Are you getting my point? Because I don't want to repeat any price candy, so I will try to reduce the window size and see if the total frequency or total number of unique candies in that subarray still matches the frequency of the candies. Okay, so in this way what will happen is I will ignore a lot of subarrays without calculating them. So for example, here I was calculating n square subarrays. Okay, here what will happen, let's say this is a subarray, it contains f dash number of unique candies. If this is less than f, then what I will do is I will increase the subarray size from the right hand side until this f dash matches f. Okay, so now see what will happen is, now this is the right pointer, this is the left pointer. Now this right pointer will never come back. Right pointer will move forwards and left pointer also will move forwards only. Now right pointer will not move backwards, and this L and R represents a subarray. So what I am trying to say is that I moved this right pointer to the right. So if this subarray couldn't contain all the unique candies, so I moved this right one step forwards. Okay, so what are the subarrays which I will never calculate? I will never calculate the subarrays from L plus 1 to R minus 1, because if this is R, this is R minus 1. I will never calculate subarrays from L plus 2 to R minus 1. I will never calculate subarrays from L plus 1 to R minus 2, and so on. And there is no need to calculate, because if from L to R minus 1, if the number of unique candies are less than total number of unique candies, then from L plus 1 to R minus 1, obviously this f dash will be less than f. From L plus 1 to R minus 2, obviously it will be less than f. From L plus 2 to R minus 1, obviously it will be less than that. So what are we trying to do is, we are trying to minimize the number of subarrays which we are checking from n square to some decent value, and hence our time complexity will reduce. So this is the first case in which we will ignore a lot of subarrays. This will never be checked. Another is, let's say this is the subarray from L to R, and here the frequency is equal to f. So I have the sum value, that is the sum of cost of candies of this subarray stored. I will compare it with my answer variable. Now I will try to decrease this subarray. So I will take L to L plus 1. Now with this also a lot of subarrays will be ignored. Which subarrays? See what I said, now L or R will not come back. Basically there is a particular subarray, will increase the size if frequency is less than total frequency, and will decrease size if frequency is equal to total frequency. So I decreased the size of this subarray by increasing L to L plus 1. So what will happen is, what are the subarrays which will never be calculated? Subarrays starting with L and ending at R plus 1 will now never be calculated, because R can go to R plus 1, but L has come to L plus 1. So now it will not come back to L. So these subarrays will never be calculated. This subarray will never be calculated. Up to this subarray will never be calculated. And there is no need to calculate this. Why? Because from L to R, if I have all unique candies, then from L to R plus 1, I will obviously have all unique candies. From L to R plus 2, I will obviously have all unique candies. But this will increase my expenditure, and I want to minimize the expenditure. So there is no need to calculate this, because if I increase the elements, expenditure will increase. So the cost of all these subarrays will be greater than L to R only. So there is no need to calculate this. Now when I am taking L to L plus 1, it might be possible that L plus 1 to R also contains all unique candies, because the element which was coming here might be repeated. For example, here the cost was 2 and the 2 cost candy is repeating here. Are you getting my point? So it might be possible that L plus 1 to R also contains all unique candies, and its cost will be less than L to R. Are you getting my point? So in this way, we will ignore a lot of sub-arrays and hence our time complexity will reduce. Now, let's try to dry run it on this and this example, and then we'll move on to the actual code. So now let's dry run it. So first of all, let's say my sum variable is 0 and initially let's take my answer variable as -1. First of all, my L and R will both be here. Okay, so this is 1, 1, 1. 2, 2, 3, 4, 5, 1, 5. Okay, my L and R both are here and my F value is 5. Now when L and R both are here, my current frequency is what? Let me take it in current variable. It is equal to 1. I have only one unique candy whose price is 1. It is not equal to this. So I will increase my subarray size. So my subarray size will become this much. I will increment R. This is also 1. So my current variable will remain 1 only. This represents what? Number of unique candies, means number of unique price candies. And if this becomes equal to F, then only I'll compare that subarray cost with my answer. Why? Because Geek wants to test all different candies. Okay. So my sum will become, from 0 it will become 1, from 1 it will become 2. Now I'll again increment this, so the sum will become 3. But this current will remain 1 only. So I'll again increment the subarray. Now the current will become 2. And my sum will become 1 plus 1 plus 1 plus 2, that is 5, and 2 is still less than 5, so I'll still increase the subarray. So this will be my subarray. So still the current will remain 2, but the cost will become 7. So now I'll again increase the subarray. Now this year the current will become 3 and the cost will become what? 10, right? Because this subarray is 1 plus 1 plus 1 plus 2 plus 2 plus 3, okay, 10. And the current will become 3. So I'll again increase the subarray, right? So now this will be my subarray where the current will become 4 and the cost will become 14. Still 4 is less than 5, so I'll increase the subarray. So this now the current will become 5 because we have all 5 unique candies. So this will become 5 and this will become 19. Okay, is it 19? It was 10 till here and then 19. Now since current is equals to F, it means in this subarray I have all unique candies. So I will compare the price or cost sum of this subarray with my answer variable. Since answer is -1, so I will initialize it with 19. Okay. If it was not -1, I would have taken the minimum value of answer and the subarray cost. So this becomes 19. Now since here the current value is equal to F, so I will keep decreasing the subarray size until current remains equal to F. Okay. And if it becomes less than F, then I will again stop there and increase the subarray. So now my subarray will become this. Okay. From this one to this 5. And the cost will become 18 because this has gone. Right. Now again the current will remain 5 only. We have all 5 unique values, so my answer will become 18. Again I will decrease the subarray size. Again this will go, so cost will become 17. And again I have all 5 unique candies, so answer will also become 17. Again I will decrease the subarray. Now it will become this, but now I have 2, 3, 4 and 5 only. I do not have 1, so my current will become 4 and I will stop here. Again I will increase the subarray size. So now the subarray will become this much. It has 1, so again my unique values will become 5 and cost will become how much? Okay, so the last time cost was 17. It was for when I removed this element, the cost will become 16. And now I again add this element, so cost will again become 17, right? 2 plus 2, 4 plus 3, 7 plus 4 is 11 plus 6 is 17. But answer is equal to 17, so will not change it. But again I have all unique elements, so I will decrease the subarray size. So I will take this subarray, okay, this subarray, and this also contains all unique values. My cost will become 15 because I have removed this 2, and 15 is less than my answer, so I will make answer equal to 15 because the number of unique candies is 5 only. And then what I will do, I will again decrease the subarray size. So now my subarray will become this much. So the number of so this current will become 4 because the number of unique values are 4, and the cost will become how much? 13. But since this is not equal to F, so I will not compare 13 and my answer. Instead I will increase my subarray size. So I will increase, but still the current value will remain 4 only because 5 is already here. So, and now if I increase the subarray size, we will go out of bounds, so I will stop, and hence my answer is 15. The minimum expenditure is 15, and what will be that? It will be this subarray. Sum of first 5 elements is 5 into 6 by 2, that is 15, right? 5 plus 4 9, 9 and 1 10 and 5 15, and hence we have got the correct answer. Now two things. What will be the time complexity for this? Time complexity would be big O of n only. Why? Because our right pointer will scroll over n elements, left pointer will scroll over n elements, right? So we are not generating all subarrays. So it will basically be 2n, but 2 is constant, so I can remove 2 and I can say my time complexity would be big O of n, right? Another thing, how will we maintain this current and f value? So f, I can basically count how many different values are there. How can I update the current value with respect to subarray? Like each and every time I cannot traverse the subarray completely and check the number of unique elements. I need some method which can do this for me in constant time. So what I will do is, I will maintain one count array which will maintain the number of candies of a particular price in the current subarray. So for example, that count array, here the prices are between 1 and 5 only, so let me take that count array of size 6. So this will have indexes 0 1 2 3 4 and 5. Let's say I am talking about this subarray. So count of 1 will be 2, this will be 0, count of 2 will be 2, count of 3 will be 1, 4 will be 1 and 5 will be 1. Okay. Now whenever I am incrementing the subarray, the new elements whichever come, for example this is the new element, so I will make the count of 5 as 2. Whenever I am decrementing the subarray, so if I am decreasing, I am removing this element, so count of 1 I will decrease by 1 and this will become 1. This can be done in constant time. Whenever the count array after incrementing becomes 1, it means we have got a new candy. For example, if I have 1 2 3 4, if I am currently under this subarray, and if I increment my subarray size, then count of 4 will become 1. 1 means this has occurred for the first time, so I will increment my current counter. Okay. And whenever I decrease a subarray, for example I remove this element, then I will say count of 1 minus minus. Now count of 1 was how much? Count of 1 was 1 only in this subarray. So whenever count of a particular element becomes 0 after removing that element, it means now there are no elements of this index remaining or this price in the current subarray. So in that case I will say current minus minus, that is the current unique elements in my subarray. Okay. So this will be done in constant time in this way. Let's dry run on this quickly. So this is 1 2 2 4 2. So first of all I'll take this subarray, my sum would be equal to 1. Number of unique elements will be 1. Then I will take this subarray, my sum will become how much? Let me write down sum here. My sum will become 3. Number of unique elements are 2. Then this subarray sum will become 5. Number of unique elements are still 2. Then this subarray, the sum will become 9. Number of unique elements are 3, which is equal to f. So I will store 9 in my answer. And I will try to decrease the subarray size. So I will remove one element. Now this contains only 2 elements. So again my current count will decrease and my sum will become 8 because I have removed this element. Then I will increase the subarray, so my sum will become 10, but the unique elements will remain still 2. Then I will again try to increase the subarray, but I will go out of bounds, so I will stop and I will return 9 as my answer. Okay, I hope you have understood this. Now let's look at its actual implementation. So if you look at the actual implementation, so what I have done here is, first of all I have taken one f value which will store the number of unique elements totally. Current will store the number of unique candies in the current subarray under consideration. This is the count array which is of 1001 size, because the prices range from 0 to 1000, 1 to 1000 it is given in the question. I have taken some variables. I have taken answer as a very large value initially because I want to minimize it, so I can use the minimum operator. And sum is initially 0, which will represent the sum of cost of candies in the current subarray under consideration. Initially I have marked count of I as 0, and then I have traversed the array and I have increased the count. Then what I have done is I have again traversed from 0 to 1000, that is the different unique prices possible, and if the count of a particular price is greater than 0, it may be 1, 2, 3 or 100. For one price there may be 100 candies. Then I have to increment my f value once only because all of them are same candies, and f will store the number of unique candies. Then I will again mark this count as 0 because now I want to use it for counting the number of unique candies in the current subarray. Okay. Then what I have done is I have taken two variables I and j. I will represent the left part of my subarray and j will represent the right part. At every step I will increment j by one step, and at every step I will decrement I will also increment I and decrement the size of the subarray until the number of unique elements in that subarray is equal to total number of unique elements. So j will increase once by at each step. So count of candies of j plus plus, and the sum will also increase by this much cost. If the count of candies at jth position is 1, it means we have got a unique candy. So unique count candies plus plus. Now until the unique count candies equal to the total unique candies in the whole array, I will keep decreasing the subarray. So I will keep incrementing I. So first of all, I will compare answer equal to minimum of answer and the sum of the current subarray, because this subarray contains unique number of candies equal to total number of unique candies. Then I will remove the candy at the ith position. So count of candies of I minus minus, its count will decrease. If count becomes 0, it means we have lost that price candy. So I will do current minus minus. I will also remove it from the current sum of price of candies, and I will do I plus plus. This process will keep repeating until current is equal to f. Okay, so until the unique frequency candies does not decrease, this will keep on repeating. Then we'll come out of the for loop. So when we come out of the for loop, we have a subarray where the unique number of candies are less than f, because then only we will come out. Then we will again increment the subarray by incrementing j at the next position. And finally, I will return answer which will store the minimum cost out of all possible subarrays which satisfies the given condition. I hope you understood it. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Now let's move on to the fourth question. So now let's look at the last question for this contest. This is forest escape. First of all, let us start by understanding the question. What does it say? There is a forest represented by a grid of n rows and m columns. At t equal to 0 seconds, some of the cells are fired. So we have a grid of size n cross m which represents a forest, and at time equal to 0, some of the cells are fired. Every second the fire spreads to the 4 adjacent cells. So if there is a fire at t equal to 1 at a particular cell, at t equal to 2, their adjacent cells will also get fired up if they are not already fired up. Okay. A man is stuck in the forest. In 1 second he can move by one cell to the right, left, up or down. Okay. So here also adjacent cells means left, right, up and down. And there is a man who is at a particular cell initially, and in 1 second he can move one cell to the right or left or up or down. If he reaches the sides or corners of the grid, he will save his life. So see, if he can reaches the sides or corners means either in the first row or first column or last row or last column, any cell if he can reach, then he will be able to save his life. Now why are there chances he cannot reach? Let's say he is surrounded by fire from all the 4 sides, he cannot move further. Okay, so a man can only move in a cell if it is not already fired up. Okay, your task is to find out if there is a path exists such that he can escape avoiding the fire. So we need to tell whether he can escape the fire or not. Consider zero based indexing. So we need to consider rows from 0 to n-1 and columns from 0 to m-1. The fired cell is marked as X, the initial position of the man is marked as M, and all the other cells are marked as dot. So we will be given a grid of size n cross m which represents the forest, where X would be initial cells which are fired at t equal to 0 seconds, M will represent the initial position of the man, and dot will represent nothing. Okay. So for example, if we look at this cell, here n equals to 3, m equals to 3, and here the output is yes, man will be able to escape the fire. Now we'll see the explanation of this test case further. So I am just not going in detail right now, but this is how the input is. Here the man is here and these are the initial cells fired up, and here the output is no, man cannot escape. Okay. You don't need to read input or print anything. Your task is to complete the function escape forest, which takes two integers n, m, that is the number of rows and number of columns, and a grid of characters grid respectively, and returns true or false. True when the man is able to escape the forest, and false when man is not able to escape the forest. Constraints are given here. So now if we think about solving this problem, then first of all let us briefly understand in a better way what the actual problem is. So basically there is a n cross m grid which represents a forest. X represents the cells where at t equal to 0 the cells are fired up. Okay, so there is fire. M represents the position of the man at t equals to 0. In 1 second the fire can go to adjacent cells. So in 1 second this cell can fire the adjacent cells. And dot represents nothing. Okay, so these are the cells where the man is not there in the initial positions and which are not fired initially. In 1 second, if a cell is fired, it can fire up the 4 adjacent cells. So let's say this cell is fired. Okay, so in 1 second it will spread fire here also, here also, here also, and here also. Okay, also if a man is at this position, in 1 second he can move here or here or here or here. Okay, this much clear. This fire can fire all the 4 adjacent cells in 1 second. Okay, and man will be able to move in any one cell at adjacent cell at a time. So the fire will spread and man will try to escape. So we need to return true or false if the man can escape from the forest. If we need to return true if the man can escape, and we need to return false if the man cannot escape. Okay, now what is the definition of escape here? Here the man is said to escape if he reaches any of the cells which are on the border or on the corners. Okay, so either this or this or this or this, these are the corner cells and these 4 are the border cells. Okay, so if he can reach basically any cell in the first row or first column or last row or last column, he will be safe. Now how can he reach? See, he can only move into a cell if the fire has not reached there yet. Okay, so in this case what will happen? See, this cell will fire this cell at t equals to 1, and this cell will fire this cell at t equal to 1, and this cell will also fire this cell at t equal to 1. Okay, where the man is initially, but at t equal to 1 man will come here, and here fire has not reached yet, and this is a border cell, so man will be able to escape. So the answer would be yes. Okay, here what will happen? See, man cannot move in any of the adjacent cells because all these 4 cells are fired at t equal to 0. Okay, and at t equal to 1 this cell will fire this and 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 this. So basically all the cells will be fired. Also all the 4 cells will also fire the center cell. Okay, so basically man will not be able to go anywhere, and hence the answer would be no or false. Okay, now how would we solve it? So see, basically what we will do is, for all the cells we will take 2 values. One is the time at which fire reaches that cell first time. Okay, now why am I telling first time? Because consider this case. Okay, or let's say consider this case where there are 5 columns and only 1 row. Now at this cell, from here fire will reach at t equal to 3, because this is t equal to 0, here it will t equal to 1, here t equal to 2, and here t equal to 3. But because of this fire, here the fire will cause at t equal to 1. So what I am trying to say is, this cell will get fired at t equal to 1 only, right? So one cell may get fired up due to multiple cells, but we need to see when it gets fired up for the first time. So what we will do is, we will calculate the time at which each cell gets fired for the first time. Then we will calculate the time where the man can reach at the earliest for every cell. Okay, so for example, let's say if this is the example, then here man is at t equal to 0, here he will be able to reach at t equal to 1 at the earliest. Okay, otherwise here he can reach at other time also. Suppose man is here, then he comes here, then he again goes here, and then goes here. So t equal to 0 was here, t equal to 1 will be here, t equal to 2 will be here, and t equal to 3 will be here. But we are talking for the first time when he can reach a particular cell, because he wants to escape, right? So he will move as fast as possible. So we will also calculate the fastest time when a man can reach to a particular cell, and then we will compare that with the time when that cell gets fired up. If the earliest time when the man is able to reach that cell is less than the time when it gets fired up, then man will be able to reach there. For example, for a particular cell, man can reach there earliest at t equal to 3, and this gets fired at t equal to 5 for the first time. Since this is less, man will be able to reach this cell and move forwards. But if this was greater than equal to 5, then this cell would have already been fired, so man would not be able to come here, right? So we will then compare this, and then we will see whether there exists a path such that man will be able to reach any of the border cells or the corner cells. So if I write down the examples for this two, so if I let's say if I write distance, okay, so I'll take two 2D arrays. One is distance. In this this will store the time when cells are fired first time, okay, or basically when the cells are fired, okay, because of some other cell. Here using the word first would not be very perfect, but you got the point, right? The first time when that cell gets fired. And I will take one more 2D array dm. This is basically distance of men from that cell, okay, and this is distance, okay. That's why I have used these words, because moving one unit of distance take 1 unit of time. This will basically store the time when man reaches that cell first time, okay, or the fastest, okay, when he can reach there fastest possible, okay. So if I write distance, this will be a 2D array of numbers where it will denote the time at which fire gets caught up in that cell. So for the, so if I write like this, okay, it is 3 cross 3 I am writing for this example. So this will get fired up at t equal to 0 only, this will get fired up at t equal to 1, this will get fired up at t equal to 1, and this will also get fired up at t equal to 1, right? Because this and this cells will be fired by this, and this cell will be fired by this. Now this will get fired at t equal to 2, this will get fired at t equal to 2, this will get fired at no, this will not get fired, this will get fired because of this, this will get fired because of this, and this will get fired because of this, and this will get fired at t equal to 3. Now I write dm. Also please remember, we are not only comparing the border cell time when it gets fired with respect to the border cell time when the man reaches there. We need to compare the time of each and every cell on the path, because if the man cannot move through a particular cell, he cannot move further, right? So we do not only compare the time of the border cell with the man's time to reach there. We will compare the whole path. Even if one cell is not reachable, we cannot go further, right? So man was initially here, so here he was at t equal to 0. Now here he can reach earliest at t equal to 1 because he can just go there. Here also he can reach at earliest at t equal to 1. Here also he can reach earliest at t equal to 1. Here also he can, here also he can reach earliest at t equal to 1. Now from here he can go here or here. So this is t equal to 2, this is t equal to 2, and this is t equal to 2. Now if I compare, see, this takes fire at t equal to 1, and this is man is here at t equal to 0. So he is safe. Now this takes fire at t equal to 2, and man can reach here at t equal to 1. So I will come here, okay, and this will be a safe position. Even man this also gets fired at t equal to 2, and man can reach here at t equal to 1. So man can also come here, okay. Then this is a border cell, so these two are safe. Here the fire gets caught up at t equal to 1, and here the man can reach at t equal to 1. So this is not a safe cell, you cannot go here, okay. So before calculating the value of dm, I will check off these things, okay, whether I can move here or not. So in this way I will fill this table first, now I am talking about implementation, and then I will try to fill this cell, and I will only fill those cells where I can reach. So before I go to this cell, I will see that I can reach here at t equal to 1. What is the time it gets fired? If it is greater, if the time when it gets fired is greater than the time when I can reach here, then only I will go here, because then only it is safe for me. And during this process, if I am able to reach on any of the border cell, then it is safe. Also one more thing, now since we are talking about implementation, so this is basically the concept. How will we implement it? So what I can do is, see, what I can do here is I can apply, I can use a queue where initially I will push all the elements which were fired at t equal to 0. Right, then their adjacent cells which were not fired initially, I can push them back inside the queue and pop out these elements one by one. So those will be the cells which get fired up at t equal to 1. Then again I will pop out those elements and push back in the queue their adjacent cells which are not fired yet, and give them t equals to 2. So for example, if I talk about this, okay, then in my queue I will have this cell and this cell, and I will mark distance of this cell and this cell as 0. Now I will pop out this element and see their adjacent cells which are not fired initially. So this is not fired initially. So since this is fired at t equal to 0, this will be fired at t equal to 1. So I will mark this as 1 and I will push this inside the queue. So initially let me write down the name of the cells. So let's say this is A, B, C, D, E, F, G, H, I. So initially in my queue I have F and I. Okay, I'll pop out F and push their adjacent cells, that is C and E. So I will pop out this and I will push E and C, and I will mark their distance as 1. Now I will pop out I and push their adjacent cell, that is H, and mark it as 1. Okay, now I will pop out E and push their adjacent cells which are not fired yet, that is B and D. So I will push B and D, and since this caught fire at t equal to 1, this will get fire at t equal to 2. Okay, so E is also gone. Now I will pop out C. So their adjacent cell is B and D, but they are already in the queue, so I will not push them again. So I will pop out this. Then I will pop out H, and their adjacent cell is G. So I will push G, and I will mark it at t equal to 2. Okay, and I will pop out H. Then for B, A is the adjacent cell which is not yet fired, so I will push A in the queue and mark this as 3, because B gets fired at t equal to 2, so this will get fired at t equal to 3. Now no more adjacent cells are left, so simply this will all get popped out one after the another, and we will get this table. Similar thing we will do for the men's table, but here instead of pushing multiple elements in the queue initially, we will only push one cell where the man was initially, and then calculate the time. Okay, now let's look at its actual implementation for better clarity. So now let's look at the actual implementation. The implementation is quite long, and you can also divide it into functions for better modularity, but I have not done here that. Okay, so see, this is the vector of a forest which will have x, m, or dot initially as per the question, and then this is number of rows, this is number of columns. First of all, I have marked answer as false. Okay, I have taken by default answer as false, and if I will be able to reach any of the border cell, I will mark answer as true. I have taken no fire equals to true. What does that mean? No fire means there is not even a single cell with x, means which is fired initially. So if this remains true, it means there are no cells which were fired, so man can definitely escape. Okay, so if no fire is true, I will simply return true. Okay, then I have taken queue and I have the data structure I am putting inside the queue is pair. Why? Because each cell, to represent each cell, we need row number and column number, so I have taken pair. Then I have taken some variables. I have distance and dm. What does distance represent? It will represent the time at which a particular cell gets fired up for the first time. dm will represent, dm of ij will represent the time, the minimum time at which the man can reach the cell i comma j. Then initially I have marked all of them as -1 by default. Okay, then I will push all the cells inside the queue as I told, who are initially fired. So for I equals to 0 to n, j equal to 0 to m, if that cell is fired initially, first of all mark no fire as false, because we have found a cell which is fired up. Then distance of ij equal to 0, because these are fired at t equal to 0, and inside the queue push back the row number and the column number. Now if after coming out of this, if no fire still remains true, it means there is no cell with value x, then I will simply return true, because the man can reach out, because there is no cells fired. If not, now while the queue is not empty, I'll repeat the process which I told. I'll remove the first element. It is kind of breadth first search, if you know. Okay, this is breadth first search we are applying, where we find the minimum distance of the graph when it is not weighted. Okay, so even if you don't know that, don't worry, I hope you understand this approach, right? So basically if you look at the queue, initially we have elements with distance 0, then we have elements with distance 1, then we have elements with distance 2, and so on. And once an element is pushed inside the queue, we do not push it another time, right? Because it is already pushed, so its minimum distance is already calculated. and minimum distance means the first time when it caught fire. Okay, now so while Q is not empty, first of all take out the first element. So I will store the row number and J will store the column number. Then I will pop out that element from the Q. Then for a particular cell, see, for a particular cell ij, I can move right, that is nothing but I comma j plus 1. I can move top, that is nothing but I minus 1 comma j. I can move bottom, that is nothing but I comma j, I minus 1 comma j, and I can move left, which is nothing but I comma j minus 1. So that is now what I am doing. Also one more thing, how I did here, you can also do here. So here if I write down the distance table, then it would be this is when will the fire gets caught up. This is 0, this is 0, this is 0, this is 0, this is 1, 1, 1, 1 and 1, and man is initially here. So man cannot move at any of the adjacent cells because they are all fired, and hence the output will be no. Okay. So now here see, what I am doing is, after removing the row number and column number, I am trying to check for the adjacent cells which are not yet fired. So first of all, I am checking for I j minus 1. Now in order to check this, I also need to check whether j minus 1 is within the conditions, that is j minus 1 is greater than or equal to 0. So if j minus 1 is greater than or equal to 0 and distance of I j minus 1 equals to minus 1, means it is not yet fired. Okay. Then distance of ij minus 1 equals to distance of ij plus 1. Why? Because distance of ij, let's say it gets fired up at t equal to t seconds, then this will get fired at t plus 1 seconds. So this plus 1, and I will push it inside the q. So q dot push I comma j minus 1. Similarly for ij plus 1, I minus 1 j and I plus 1 j. So my distance table will be ready. Now what I need to do is, I need to start the same thing with the cell where the man is initially, and I need to calculate distance of man table, right? So I have traversed the 2D grid, and wherever there was man, I have marked this distance as 0. I have pushed that element inside the queue and braked. Why braked? Because there is only one cell where the man will be there. Again the same process, while queue is not empty, pop out the row number and column number. First of all, if the row number or column number is first row or first column or last row or last column, the man has reached a border cell or a corner cell, immediately mark answer as true and break. Because this represents what? That the man has reached here. I will only push the cells inside the queue where the man can reach. Okay, so I will check the conditions and then only push that element inside the queue. So if this element was present inside the queue and if it has popped out, it means the man has reached the border cell. Okay, again the same conditions. If distance of man I minus 1 j, again the 4 adjacent cells, is minus 1, means the man has not reached there yet. We have not calculated the time of it yet. Then only we'll move forwards. Now tell me why I have not checked here if I minus 1 is greater than or equal to 0, which I have done initially. Because here I minus 1 would always be greater than or equal to 0. When will I minus 1 not be greater than or equal to 0? Means I minus 1 is equal to equal to what? Minus 1. That means I equals to 0, right? So this will not be greater than 0 when I equals to 0. And if I is 0, it means we will mark answer as true and break. So we will not come here only. It means if we are coming here, the cell is not a adjacent or a border cell. That's why I am not adding that condition here. Okay. Now for the I minus 1 j adjacent cell, if its distance is not calculated and distance of fire of I minus 1 and j cell is greater than distance of man of ij plus 1. Understand this. What will be distance of man of cell I minus 1 j? It will be distance of man to reach ij plus 1, because it takes 1 second to move to an adjacent cell. So distance of man of ij plus 1, if this time is less than the time of fire which reaches the cell I minus 1 j, then only the man can go there. So that's why I have added this condition. So if the distance of man is minus 1, so it is not calculated yet, and the distance or the time taken by fire to reach there is greater than the time taken by men to reach there, then only the men will go there. So I will update distance of men I minus 1 j as distance of men ij plus 1, and I will push that element inside the queue. And similarly I'll do for the all 4 adjacent cells. And if so, in my queue I will have only the cells where the men can reach. Are you getting my point? So if at any time I pop out an element with first row or first column or last row or last column, it means man has reached there before the fire, and hence I can mark answer as true. Similarly, this process will repeat until I get answer as true or the elements from the queues are popped out, and finally I will return answer, that is either true or false. What will be the time complexity here? It will be big O of n cross m, because inside the queue I am pushing n cross m elements, popping out n cross elements, and I am doing this 2 times. So basically it will be 4 into n cross m, but 4 is constant, so I can say n cross m. And what is the auxiliary space? The auxiliary space here is also big O of n cross m. Why? Because we are taking this distance array, then in the queue also there will be n cross m elements at max, and so on. That's why this is the time complexity and this is the auxiliary space, and finally we will return answer which will either contain true or false, whether the men can reach the border or the corner cell or not. Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely, and I hope you have understood all the 4 solutions very well. Thank you.